Hello everyone, I am Dr. Naresh Kumar, Assistant Professor from the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today we are going to have a discussion on single phase off-bridge inverter with R load and L load. So first one is here, the inverters are classified into two types, voltage source inverter and current source inverter here. And in the voltage source inverter again classified into single phase and three phase, and in the single phase off bridge inverter and full bridge inverter, and in the three phase inverter there is a 180 degrees conduction mode and 120 degrees conduction mode. So here in the single phase of bridge inverter we are dealing, now we are going to explain with R load and L load. First, let us understand the R load, single phase off bridge inverter with R load. This is the circuit diagram. This is the circuit diagram of a single phase off bridge inverter with R load. This is the R load. First, here VDC by 2, VDC by 2. Here two switches. Here these two switches are here bidirectional switches. So the bidirectional switches may be either MOSFET or IGBT. Here bidirectional switches means here, so this one either thyristor and again one diode. Here this is the bidirectional switch. So here these switches are operated in complementary fashion. First one is here from 0 to T by 2. S1 will conduct and S2 is conducting for T by 2 to T. So here when S1 will be on, S2 will be off, and when S2 will be on, S1 will be off. 0 to T by 2 only, S1 will conduct, S2 will be off, and T by 2 to T, S2 will be on and S1 will be off. So here first one. So now here if you apply KVL from 0 to T by T, S1 when S1 will conduct. So here if you apply KVL, so what will happen? So here if you apply KVL, so minus VV plus minus VDC by 2, this is the output, plus V naught equals 0, VDC equals to V naught. So now here there is no current flowing through this diode. Diode will not conduct, only S1 thyristor, S1 switch will conduct. And next from in this duration only S1 will conduct, S2 will be on, S2 will be off, and next S2 will be on, T by 2 to T. So now here in this minus VDC by 2 plus and minus VDC by 2 and minus V naught. So now here minus V naught. So now here VDC by V naught equals to minus VDC by 2. So here this is the case, S2 is on and S1 is off, and here in this case S1 is on and S2 is off. So now here the duration for S1 on and for S2 on. So now here if you see the waveforms, so these are the output voltage waveform, output current waveform, output voltage waveform, output current waveform, switch current and diode current. So that I am drawing. So first here, so here total time period is T. So here this is T by 2, T by 4 and 3T by 4. So now here output voltage from 0 to T by 2. From 0 to T by 2, S1 will be conduct. So here S1 thyristor will be conduct, and from T by 2 to T, S2 thyristor will be conduct. So this output voltage is, so that is VDC by 2. And this is the minus VDC by 2. S2 is on and here S1 is on. So 0 to T by 2 only, S1 will be on and S2 will be off completely. And next here S1 is off. So this is the output. And next, what about the output voltage, output current? Here this is a VDC by 2. And what about the output current? This is the R load, is a voltage type of load. It will follows the supply voltage without any deviation. It will starts from 0. So here there is no deviation in between V naught and I naught. V naught equals to I naught equals to V naught by R for R type of load. So now here this is a VDC by R, I naught by R. This is V naught means VDC by 2. And next, what about the switch current? Switch is only one switch is conducting only in the, so here switch S1 will conduct only up to T by 2. Again next during T by 2 to T2 thyristor will conduct, that output voltage is, so this I naught. And next, what about the diode current? Diode current is 0. So there is no diode for R load. There is no current in the diode. In the inductor type of load, pure L load, RL load only, the diode current is present. There is no current, so the diode current is 0. So these are the four waveforms: output voltage, output current, source current, switch current, and diode current. And now here, if you see the, this is the I naught and this is the output diode voltage. And now here, if you calculate the total output voltage V naught equals to, so this output voltage, output RMS voltage equals to, how you will calculate the RMS? This is the square waveform. So square this waveform, this is the average. So now this is VDC by 2, and square this waveform means this is VDC by 2 and take an average. And next here, take an under root. So now this RMS value of this output voltage is, so V0 RMS equals to VDC by 2. And next, what about this Fourier series equation? So any square waveform, any periodic waveform resolving into a series of sine waves with different frequencies. So here this is the series of sine waves. So here, what is the formula for any output, any Fourier series, that equals to sigma n equals to 1 to 135 to n. So now here 4 Vs by here n into pi sine omega t plus n omega t plus 5. Pi value is 0 here. So here Vs equals to VDC by 2. VDC by 2 means here 2 VDC only. So this is the output voltage Fourier series waveform, Fourier series equation. Sigma n equals to 135 n 2 VDC by 2 pi sine omega nt. Now here, what about this fundamental component of this output voltage is here. So here, fundamental component of output voltage means any sine a square wave is resolved into here fundamental component. Only first n equals to 1 means that is fundamental component. Next, second one is the that frequency is 3. So now here this is a fundamental component. So this V01 T is always greater than, so VDC V naught of T. Here, fundamental component of output voltage is always greater than this total output voltage V01 equals to, so just substitute n equals to 1 and here n V2 VDC by pi sin omega t. So now if you calculate the RMS value of fundamental component of this is output voltage, and now here this is the maximum value V01 maximum equals to 2 VDC by pi. So now here current I am calculating. Current means divided by R. So now here this is the current is also fundamental component of current. Output current is always greater than the output current. So now this is 2 VDC by pi into R sin n omega t. So now here if you calculate the RMS value, this is the maximum output current maximum. So now this V01 maximum equals to, this is 2 VDC by pi. 2 VDC by pi V01 maximum divided by under root. So that equals to 2 root 2 in VDC by pi by root 2, that equals to root 2 VDC by pi. So this is the RMS value of fundamental component of voltage. RMS value is root 2 VDC by pi. And now here current is also same thing here. So 2 VDC by 2 VDC by pi r by root 2, that equals to root 2 VDC by pi into r. So now here, so distortion factor, that one is G equals to V01. So fundamental component of uh, RMS voltage value divided by total output voltage. So that is here, how you will calculate that one, that is equals to, here that one equals to root 2 VDC by pi, that is VDC by 2, this one. So that is VDC gets cancelled to root 2 by pi is a distortion factor, not this one. So this is 2 root 2 by pi. So now here THD equals to, how you will calculate the THD equals to, that equals to under root 1 by G square minus 1. 1 by G square means here 2 root 2 by G value is here 2 root 2 by pi. If you substitute this G value in this, so you will get the THD, total harmonic distortion value in the percentage, that is 48.43. Sorry, not 43, I think 34. So now these are the formulas: output total, output voltage RMS value, and Fourier series of output voltage, fundamental component of output voltage, and here fundamental component of output current, and next fundamental component RMS output voltage, fundamental component RMS output current, and distortion factor. There is a formula already we have discussed: V01 RMS divided by P naught RMS, that equals to 2 root 2 by pi, and THD equals to 48.34. So now these are the formulas. And next case here, uh, this is the source current, so that we will see. And next, average switch current. Here switch current or source current is same in this case. So now here we are, switch current is we are getting only in the off duration only. Each switch is 0 to T by 2 S1 will conduct, and S2 will conduct from T by 2 to T. So each switch is conducting for T by 2 to T duration only. So that is I naught into T by 2 by T only, that equals I naught by 2. And next, RMS value equals to I naught into under root T by 2 by T, that equals to I naught by root 2. So this is average switch or source current, that is I naught by 2, IS average equals to, and RMS switch current or source current equals to IS RMS equals to I naught by root 2. And next here, fundamental average switch current, fundamental average RMS switch current. So how we will get, this is the fundamental, this is the total. So now here fundamental, this is a sine wave. So that is half wave rectifier output. It is conducting, this is T, suppose this is pi and this is 2 pi. So here this is 2 pi and this is, it is conducting up to half wave rectifier output. For any half wave rectifier output average value. So what is the average value? So V0, I0, 1 maximum switch current is conduct. This is the fundamental and this one is the total. So here this I01 in, for this is the half wave rectifier output. For any half wave rectifier output average value equals to I maximum divided by pi, and RMS value equals to I maximum by 2. So now here I01 maximum, I01 maximum, this is I01 maximum. So this one, and here by pi. So this is the average switch current. And next, fundamental component RMS switch current equals to this Im by 2 means I01 maximum. This I01 is here. And now here fundamental power across load due to the fundamental. Here we have total power. So due to the fundamental and total power, and due to the fundamental and total power delivered by the source and delivered by the power delivered by each source and power across the each load here. So first one is power across load due to fundamental is here, this is cos phi. So P01 equals to V01 RMS into I01 RMS cos phi. So now here this V01 RMS I01. So here cos phi value is cos 0 is 1. So there is no deviation. Is there any deviation in the output voltage and output current? So there is no deviation in the output voltage and current. So there is no angle. That angle is 0. It is starting at 0 and it's 0. So there is no, it is a voltage type of load. It will follows the output voltage. Current is following the output voltage. The cosine angle between voltage and current is 0. Here fundamental, the this is the fundamental displacement factor is 1 only. So this one IV01 RMS I01 RMS. So now here V01 RMS means here root 2 root 2 into VDC by pi, and here root 2 into VDC by pi into R. This is the I01 RMS and this is the V01 RMS. So now here the power across the load due to the fundamental is 2 into VDC square by pi square into R. And next here power across the load, power delivered by the each source is the VDC by 2. Here this is the source. Here the what this is the source is VDC by 2 is source, and this current is the source current, fundamental source current IS01 average value. And here this IS01 average value equals to I01 maximum by pi. So now here VDC by 2, I01 maximum. So now here I01 maximum equals to, that value equals to 2 root 2 into VDC by pi into R by pi. That final value is called VDC square by pi square R. So this is only for each source. If you multiply with two sources, here we two switches. Here we have two sources. So multiplied with 2 means, so fundamental power delivered by the each source is equals to total sources 1 plus 1 2 into 2 equals to this one. So both are same. If you multiply with 2, and total power across the load is equals to, so what is the formula? P naught equals V naught RMS, I naught RMS and I naught, not fundamental. So total RMS output voltage, so that equals to VDC by, so 2 VDC by 2 and VDC by 2 by R. So that is 4 VDC square by 4R. So now here power delivered by each source is the VDC by 2 IS average. So what about the IS average is the I naught. I naught, what is the formula for I naught equals to V naught by R. So here V naught equals to VDC by 2. So now here your final conclusion is for total power delivered by each source is the VDC. So total power delivered by a source is multiplied with 2 means here you will get the same answer. So VDC square by 4. Now here all these are formulas. So now here this is for R load. And next, what about the L load? Here let us understand the single phase off bridge inverter with L load. Here is the circuit diagram for L load. So only the difference between first one and second, here load I am changing, that is pure L. So now here that switching time duration first I will explain. So first 0 to T by 2, uh, 0 to T by 2, 0 to T by 2, T1 here 0 to T by 2, S1 will conduct, as already we have discussed, and T2 to and T S2 will conduct. Here S1 S2 will off, here S1 will off. So during that period, so V minus VDC by 2 plus V naught equals 0. That equals to V naught equals to VDC by 2. Same way here during this period with T by 2 to T, so S2 will be conduct here. Minus VDC and minus V naught is equals to 0, and V naught equals to minus VDC by 2. Here S2 will be on and here S1 will be off. So now here what about the diodes? Here inductor stores the energy in the form of magnetic field, and after that it will deliver the power from the load to the source via this diode. Here in the inductor case only the diode will conduct. So here D1 and D2 diodes will conduct. Now let us understand the time duration for each switch. So first I will let me know. First here S1 is conducting. So here S1 is conducting means V naught is always positive. V naught is always positive, but here I naught is here. S1 is on. I naught is, what is the value of I naught? I naught is 0. I naught, there is no current I, but I naught equals to I naught is greater than 0. And when D1 is conduct, so when D1 is conduct, here this is the this is the I naught current is the source current, that is positive. When D1 will conduct, D1 power is delivered from source to the load. Here current is flowing in reverse direction, so I naught uh, is I naught equals to minus ID, that is negative value here. And next here S2 will conduct. S2 will conduct means, when S2 will conduct means this one is always negative. So here in this case current is, so current is flowing in this direction, this current is flowing in this direction, both are in opposite. So that is the I naught is less than 0. And next here in this case current is flowing in this direction, this is negative and this is the positive. So in the same direction, that is positive. And here switch S1 will conduct from T by, so that we will see here, this is a circuit diagram, V naught, I naught and IS, ID. So now here T by 4, T by 2 and T3, T by 4. So now here, so this is the output voltage VDC by 2 and this is a minus VDC by 2. And next here VDC by 2. So any so here I equals to in 1 by L integral of VDC. So now VDT. So any square waveform integral is always triangular. Here current is lags voltage by 90 degrees. So here this is T by 4 and this one is the T by 2 and this one is a T by 3. Here D1 will conduct and S1 will conduct, here S2 will conduct and here D2 will conduct. So here V naught is positive and I naught is negative for this one, and V naught and I naught and V naught and I naught is positive, and V naught and I naught both are V naught and I naught. This is D2, I think. V naught is negative and I naught is positive, and this is a S2. So in this way, each switch is conducting, and now here this is the I naught maximum. So this is the S1. So this one is a S2, and these are the diode currents. So D1 and D2 thyristors will conduct. So now here fundamental component of current is here less than here. This is the fundamental component of current. Here voltage is greater than, fundamental component voltage is greater than the output voltage, and here fundamental component of current is less than the output current. So now here these are the this one is here, and next here this one, and next here this one, and next here this one. These are the fundamental component of switch currents and diode currents. And now here what about the average total RMS output voltage VDC by 2, and this is the actual what is the formula for R load 2 VDC by pi n pi sine n omega t, but here this is the minus pi by 2. So here current lags voltage by pi by 2, here n square. So now here this is a this voltage divided by XL is a omega naught. So this is the voltage waveform, Fourier series total output voltage, and this is the current waveform Fourier series equation, and each thyristor is conducting for pi by 2 duration, means T by 4 duration each thyristor, these two. So this is T by 2 T by 4 duration, and this is the T by 4 duration. So if it is 2 pi means by 4 means pi by 2, and each diode is also conducting So T by 4 duration means that is pi by 2. Total thyristor duration is pi, and total diode duration is also pi. So this is pi by 2 and pi by 2, total pi, and here pi by 2 and pi by 2, that is also pi. IT average equals to, what about the IT average? This is the T by 2, T by 2, and next here 1 by 2. This is a triangle. So that is the IT average equals to 1 by 2 I0 maximum. So total output maximum voltage half into L into base, that is T by 2 by total time period. So that is I naught maximum by 8. And next here IT RMS equals to total time period is 2 pi integral of 0 to pi by 2 4 I naught, sorry, 4 I naught maximum by pi. So that is d omega t. So that is here this is here IT RMS. So this is not 4, this is 2, and now here this value is I naught maximum by pi by 2 into theta. So now here I naught maximum equals to, here I naught maximum, how we will calculate the I naught maximum? This is plus I naught maximum, this is minus I naught maximum. V naught equals to L di by dt. So now here V naught equals to L di by dt means that is VDC by 2. So now here that equals to, this is L into, so here how you will calculate this, that is minus I naught to I naught maximum. This is the time t duration. So now here I naught maximum is equals to, so now here T into VDC by 2L. So this is the formula, substitute in this. So now here what about the fundamental displacement factor? Here current lags voltage by 90 degrees. So now here the angle is 90 degrees. So fundamental displacement factor is 0. Here there is no real power, and now here power across the load due to the fundamental is V01 RMS and I01 RMS cos phi. So here cos phi equals 0 means here total this value is 0, and here is also total power across the load means I naught V naught RMS I naught RMS this cos phi. Cos phi value is 0 means here. So now here the cos phi value is 0 means here P naught equals to 0. I hope all these concepts are clear to you. If you still have any doubts in this lecture, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.